going to do is we're going to start with, in the notes, how it talked about step 1 was factoring out the greatest common monomial. Jackson, are you with me? Because here we are starting, and the two of you, Dinshaw and Jackson, are doing I don't know what. And now your names are on this video for everyone to hear when I put it on Canvas today. Congratulations. So, let's start with this. Let's do 4x squared minus 8x plus 10. So when you start to factor, the first thing you have to think about every single time is first step of factoring. Do they have anything in common that I can factor out? Can I make this problem look a little simpler? So what do they have in common? They're all divisible by 2. So I'm going to put a 2 outside of parentheses. And basically, I am undistributing a 2. So 2 times what is 4x squared? Yes. And 2 times what is negative 8x? Negative 4x. And 2 times what is 10? 5. Oh, yes, this would be a squared. Good call. Now, you can go back and check yourself, and that's the really glorious thing about factoring is every problem we do, you can go back and multiply it and see if it gets you back to the original. So, is 2 times 2x squared the 4x squared? Yes. And I made that mistake when I went back to check myself. Hopefully I would have caught it instead of Ben over here trying to catch it for me, which is good. But that's why we need to go back and check. So 2 times negative 4x is negative 8x, and 2 times 5 is 10. This is undistributing. If I go from here to here, we've done that step before. Okay, we want to take out what they have in common. So let's try another one.
Is that done yet?
We're not, that one we could keep going with, but I'm making these up, so it probably won't work. I'm just creating things. Negative 3, let's do y squared minus 9y plus, let's just do 12. Okay, so what do these have in common? They're all divisible by 3, and those of you that watched your video, its leading coefficient is negative. What does leading mean? The first, and what does coefficient mean? The number, yeah, attached to that variable. So if my leading coefficient is negative, remember how we've talked about things are just like proper ways to do something? The nice way to do it? The right thing to do, the proper thing to do is to take out a negative. Okay? You know how like we write standard form, we put the x before the y? That's just proper form. So same thing here, proper form is to factor out or undistribute that negative. So negative 3 times what is negative 3y squared? Just y squared. And negative 3 times negative 9y, or times what gives me negative 9y? Positive 3y. And then this last one? Negative 4. What you have to be very careful with is that when you are factoring out that negative, everything inside is going to change signs. Okay, and you have to be very cautious. So from here we would keep going. Right now we're going to move on to another problem, but the negative has to come out with it. Yes?
So if it was positive 3y squared and then it was still negative 9y?
That's fine. It's the leading one.
How would you keep going and how would you know when you're done?
That's what we're going to do in a minute. So right now we're just practicing step 1. All right, last one for this. Let's do negative 10y cubed plus 8y squared minus 4y. Let's change that 10 to a 12 for me, please. Sorry. Negative 12y cubed plus 8y squared minus 4y. So Grayson says they're divisible by 4. Do we agree? Negative. And it's leading with that negative, so good. Anything else?
Y. They all have y.
Gogo says there's a y in there. Do y'all agree?
Yep.
So this one has a lot we can factor out, a negative 4y. So look at it one term at a time. Negative 4 times what is negative 12? 3. And then we went from y to y cubed, so good. Y squared. Negative 4 times what is 8? Negative 2, because a negative times a negative gives me the positive, and y to y squared would just be y. And then here's where we have to be careful. Negative 4y to negative 4y. Okay, so there's a plus 1 there. What a lot of kids will do is they will leave that off. And they have nothing here. They just close off the parenthesis, and this is gone. Well, when you distribute this back, how did you get negative 4y? You don't. Okay, so there has to be a 1 there in order to finish it. Now I want to show you something else on this problem. This is the correct thing. Your first step would be to factor this out. But what if instead somebody factored out a negative 2y? What do you think your answer is going to look like?
Weird, different. Not really.
It's going to be different. Yeah, why? So it's what? 6y squared minus 4y plus 2? What do you notice about those terms?
They're all twice the amount of the first one.
They're all twice the amount. You can still factor something out. So I can factor out a 2 still. Each of these are divisible by 2. So I can take out a 2, and I have negative 2y times 2, so negative 4y. And then I would end up with what I had here. So if you start factoring, and your polynomial here is not simplified all the way, you have to go back and keep going. You have to take that out. Okay, so step 1 is to factor out the greatest common monomial, the thing that they have in common. So now we're going to work on step 4. We skipped step 2 and 3. We'll work on those later this week. Step 4 is the one that requires us to do the most practice with. So that's why we're doing it first. So I'm going to write a problem down. We're going to do 6x squared plus 7x plus 2. And in the video, we talked about having the values a, b, and c. So you don't have to, but if you want to, you could come in and label these a, b, c. And step 1, every time I factor, is to look at the problem and say, do they have anything in common?
Nope.
They do not. So I don't have to do step 1. We'll walk through step 2 and 3 later this week, but we're going to go on to step 4. Okay, so step 4 says to multiply a times c. So you're going to take a and c, which is 6 times 2, and what do I get? 12. Okay, so I want the product of a and c, which is 12. And then I'm going to list the factor pairs. What are factors? Like, what is a definition of a factor?
Numbers that go into.
Yeah, things that would multiply to get me a product. And in this case, our factors are just going to be numbers. We're not going to have any variables in there. In the video, I talked about being logical with your order. It helps so that you don't skip things. So 1 and 2 and 3 and then it loops back to 4 and 3. We don't need to write those down. Now, I want to show you something in your calculator. So grab your calculator. The calculator will give you factor pairs. Okay, now 12 is not bad. But what if you needed factors of like 300? You think there are more factors of 300 than what you just listed for 12?
Yes.
So it requires you to think some more. So I'm going to show you, if you will, if you have not, clear your calculator. So let's see if I can put this under here for the video so people can see it at home. All right, what you're going to do as soon as this calculator, there we go. You're going to go to y equals. And you're going to put your product in there. So on this problem, our product was what? 12. So you're going to put 12. Anybody not in y equals out there? Okay, and then you're going to hit divided by x. So x is up here right next to alpha. Just the button next to alpha. So it's your product divided by x. Anybody not here? Okay, then do you see where it says graph and above it says table in blue? You're going to hit second table. We don't need the graph. We want the table instead. So second graph gets me the table. Do you see 112, 2, 6, 3, 4, 4, 3. And then do you see how 5 is 5 and 2.4? If it has decimals, you're going to ignore it. Okay, we don't need it. We only want the whole numbers here that are going to get me this. Okay, so these are my factor pairs. Now go back to y equals. Let's make it 300 divided by x. So if for some reason you had a problem where your product was 300, you could come here and do you see all the factor pairs that make 300? It would be harder to come up with all of these. Okay, you could do it, but you would have to think a lot more. And this way you have that full list here. Again, you would ignore the negatives, but that would be your factors, okay? It would help you make this list.
By negatives, do you mean decimals?
Oh, yeah, I don't know what I'm talking about. Decimals is what I meant. Sorry, there's no negatives here. Just decimals. Crazy lady in the front. Okay, so we're going to put the calculator, excuse me, I got the hiccups, to the side for now. We have our factors, which means they multiply to make 12. But I need them to combine to make what? That number. 7. Why? It's B.
Oh, yeah.
Okay? They multiply A and C. Find factors that do that add to make B. So looking at my set of numbers here, what do I have? What could work? 3 and 4. And I can check it. 3 times 4 is 12. And 3 plus 4 is 7. So I told you this method is called split the middle, right? So what you're going to do is you're going to take the middle term and you are going to split it into 2 terms. So I have 3x and 4x. And then you just bring the rest of that trinomial down. Now, mathematically, is there a difference in the value of these two statements here? No. 3x and 4x makes 7x. I didn't change it. I changed the way it looks, but I didn't change its value. Questions now? Okay. What do we do next? Now we're going to add in parentheses. So we're going to come in and we're going to group them. You're going to group the first two and you're going to group the last two. Now, it's okay. Did I change the values here?
Nope.
No, because this is just addition. You can group addition any way you want. It's called, that ability gives us, or commutative property gives us the ability, not commutative property, associative property gives me the ability to group them. It doesn't matter. Okay, so now what we're going to do is we're going to look at one of those binomials, just the first one here. You know how we started by factoring something out, we undistributed? That's what we need to do. What do those two terms have in common? 3 and an x. So I'm going to do 3x. 3x times what gives me 6x squared? 2x. And 3x times what gives me 3x? 1. And I can check myself. I can do 3x times 2x to get 6x squared. And 3x times 1 to get 3x. Yes, ma'am? Can you take a 6 from a 3? You have to take what the greatest thing they have in common. Now I'm going to do the same thing, but I'm only going to look at the second one. What do those two terms have in common? So you're going to put a plus and a 2. 2 times what is 4x?
2x.
And 2 times what is 2? 1. Now here's what is glorious. This and this match. And if they do not match, you messed up. Now, there are problems that are unfactorable. There are other ways to solve problems that we cannot factor nicely. But if I am going to give you a problem for you to factor, these will match. And if they do not match, you made a mistake. You got to go backwards, okay? Now, basically what we have is we've got this thing right here being added to that thing right there. Okay, 2 things. They're complicated looking things, but it's just 2 things being added. What do those 2 boxes have in common? A 2x plus 1. Now, in the first box, what did I multiply 2x plus 1 by? 3x. So I have to multiply it by 3x. And in the second box, what did I multiply 2x plus 1 by?
2.
So I'm going to write a plus 2. You take the extra pieces to make the second binomial. Now, here's the reason why this works. If I was to distribute 3x times 2x plus 1, is it going to look just like this, which looks just like that? And then if I was to cover this one up, could I do 2 times 2x plus 1 to get this, which then got me that? Okay, that's my answer. I'm done. I have factored it, and you can go back and check it. You can use FOIL, or you can use your double distribute, your box method, whichever method it is that you prefer. You can multiply those two binomials, and they will get you that trinomial. So when you do a test, you have extra time, you go multiply your binomials. See if it works. Okay, you can check all of these answers. But does this line have any value different than this first line? No, I could substitute an x value in there and I would get the same answer. Okay. Now, this is a lot. Those of you that watched the video, hopefully you're like, okay, I kind of got this. Those of you that didn't watch the video, you may be a little confused. We're going to try another one. Does anyone have a question on this one before we move on? Okay, so if you're on a whiteboard, erase that one. Next problem. Negative 2k squared minus 5k plus 12. So step 1, every time I factor, is to say what? Do they have anything in common? No, but there is, but that doesn't help. There's a negative on my first term. So if there's a negative on my first term, I have to factor out the negative. Which means everything inside is going to change what? The sign. Everything becomes the opposite. So now I have 2k squared plus 5k minus 12, and I've got that negative on the outside. Some people would rather write a negative 1 as they're working over here, if that would help you. Now, we're going to ignore the negative. We don't need it right now, but you cannot ignore it forever. This dude here has to end up down here in my final answer. Do you think that on a quiz or a test that people forget that dude up there? Yes, don't do that. So I want you, when you're working, to highlight it, circle it, draw an arrow, something so that it stands out. Now, we're going to do exactly what we did on the last problem. So we have A, B, and C. Which two am I going to multiply? A and C. So 2 times negative 12 is negative 24. When you make your factor pairs, you are going to do this ignoring the negative sign right now. Just list the factors of 24. You can use the calculator. Oh, I don't know what I'm doing. I think I'm looking at the wrong problem. Sorry. Today is just not my day. I'm having a lot of issues. Okay, I got 124, 212, 3, 8, 4, 6. But this problem is different because my product is negative. If you are going to multiply two numbers to get a negative product, one of them has to be negative and the other has to be positive. So I need one negative and one positive. Because if not, I mean, what? I need them to combine to give me 5. Does 2 and 12 give me 5? No. Do 3 and 8, when you add them, give me 5? No. So it's not even working until I change one of the signs. So which pair is going to work for me? 3 and 8. Okay, and I need it to be a positive 5. So which one's going to be negative? The 3. And I can check. is negative 3 times 8, negative 24. It is negative 3 plus 8, a positive 5.
Yes.
One of the biggest mistakes is people doing it the other way. It multiplies to be negative 24, but does 3 plus a negative 8 add to give me positive 5?
No.
No. So we're going to use the negative one with the 3. Anyone confused with where that came from? All right. Now, when you go to do this, when you split the middle, it does not matter which one you write first. Okay? It is easier if one of them is negative and one is positive to write the negative one first. Okay? So I would suggest if you have one negative, one positive, you write the negative answer first. Bless you. You will get the same answer, but it is a little more straightforward this way.
Do we have to keep the negative? Like,
I just ignore it till the end. You can write it as you go, but it tends to get a little more confusing that way. So I split the middle. I can check. They add up to that 5. So my next step would be to do what? I'm going to group them. I'm going to add in my parentheses. Bless you again. And I'm going to look at the first set. What does that binomial have in common? A k. That's it. Just a k. K times what is 2k squared? 2k. And k times what is negative 3k? Negative 3. Now, if I'm doing this correctly, over here, I will have 2k minus 3, right? Here's what you cannot do. You cannot assume that you are awesome 100% of the time and just write 2k minus 3. Because kids who do that don't actually get 2k minus 3 there. They just pretend like they do, and then you're wrong. So be cautious. We are not awesome 100% of the time. We make mistakes. I've already made like 15 of them today in class. So, you know. All right, what do they have in common?
4.
So a 4. And I'm assuming this is a 2k minus 3, but I can check. Is 4 times 2k 8k?
Yes.
And is 4 times negative 3 negative 12?
Yes.
All right. Questions there? All right, now I have two things being combined. There's one and there's one. What does each of those things have in common? 2k minus 3. So I'm going to factor that out. What am I going to have to multiply 2k minus 3 to get this? K. And what am I going to have to multiply over here? Plus 4. Am I done? No. I have a negative. I plop it right in the front, and I am done. That's it. And you could check it. You could FOIL these out. You could use the box, whatever method. Then distribute that negative, and you would get back to where you went. Yes, sir?
In your answer also, so like you can multiply a negative by 2k minus 3, so you plus 3.
The best way to write it is with a negative on the outside. Like, that's just kind of proper form. Mathematically, it is the same if you were to multiply it back.
Okay.
Okay, but like on a test, I'd take off a point, you know, or two if you put the negative back in. Okay, it's just the right form to do it in. All right, how are we feeling? All right, anyone have a question? Okay, so I'm going to start you on the next one. I'm going to have you finish it.
I think the big thing is just going to remember the steps.
Yeah, but the good news is if you have to remember the steps, like we're doing the same steps every time.
Yeah.
So you've got a constant process going. 3x squared minus 17x plus 20. I'm going to start you here. This one has something in it that's kind of tricky. So first step of factoring. Do they have anything in common? Do they lead with a negative? No to both of those. So I've got my A, B, C. Which two do I multiply? A and C. So 3 times 20 is 60. So if you are unsure of all of your factor pairs of 60, you can use the calculator to help you come up with those. You go to y equals. You do 60 divided by x, and you go to second graph, and it would get you the factor pairs. 60 is not horrible, but sometimes our brains are tired. I'm going to tell you this is a commonly missed problem. Okay, so I need two numbers that are going to multiply to get me 60, and then they are going to combine to get me negative 17. So I'm going to tell you that the most common wrong thing is this right here. Can anyone explain to us why that's wrong? Grayson?
Because it doesn't multiply, it doesn't multiply into positive 60.
Perfect. So Grayson's saying this would combine to be negative 17, but what is 3 times negative 20? Negative 60. Yeah, so the only way to multiply to get a positive number is a positive times a positive, or a negative times a negative. Well, this was a positive and a negative. So that is not a choice. But it is probably the most chosen wrong answer. If I'm going to combine to be a negative, I got to have negatives. Correct? So it's got to be two negatives. Which two terms could both be negative to give me 17 there?
5 and 12.
Negative 5, negative 12. I can check my multiplication. Negative 5 times negative 12 is positive 60, and they combine to be negative 17.
Shouldn't 6 and 10 also work?
But they wouldn't be 17. 6 and 10 would be negative 16. Okay, so here we go. We're going to split the middle. Now, earlier I told you if you had one negative, you should start with it, correct? We have two negatives, so it doesn't matter. It's going to add a little bit something into the mix here in a second that we have to be cautious with. So I'm going to come through and group them, the first two and the second two. So I've got a 3x squared minus 5x. What do they have in common? X. And that leaves me 3x minus 5. So this is where you have to be careful. Do you see how there's a negative right here? It has to be right here. Now what number do those two have in common?
4.
A 4. Now, that is a negative 4 on the outside of this parenthesis. So coming back up here, I've got a negative 12x and a negative 4. What am I going to multiply that negative 4 by to get that up there? Negative 3x. But those don't match. Okay, so this is where we have to be careful. What is a negative times a blank gives me a negative? A positive. Now I have a positive 20 and a negative 4. What is this going to be? Negative 5. So negative 4 times 3x is my negative 12x. Negative 4 times negative 5 is my positive 20. Do they match now?
Yes.
All right, finish the problem. You only got one step left. So I got 3x minus 5 times x minus 4. Okay. Any questions on that one? Okay, so I'm going to give you one to do. I am not going to walk you through it. I want you just to try it. I will walk around and help you if you get stuck. So we're at 12n squared minus 11n plus 2. I'm going to pause the video if anyone is watching it. Try it on your own. Okay, so I'm going to show you the answer. Because we had a positive product, but we needed a negative combination in the middle, both of these had to be negative. if I can zoom in. There it goes. So you should end up with 4n minus 1 times 3n minus 2. Anybody stuck? Okay, so you should have used a negative 3 and a negative 8. Did anybody in here put the negative 8 first? No? Okay, if you put the negative 8 in first, you're going to get the same answer. You're just going to have this here would be split, and these two would be combined to be doubled in the middle. So it would just look a little bit different. Okay, so let me stop the video.